Now, let's work through our first optimization example step by step. We are given a rectangular garden problem. A rectangular garden is built using a rock wall as one side and wire fencing for the other three sides. We are given 100 feet of wire fencing, and we want to determine the dimensions that will create a garden with maximum area. And we also want to find the maximum area. So we want to find the dimensions and also the area. And we want to maximize the area. This is our rectangular garden. This side is the rock side. So we only use a fencing on these three sides. Let's start by defining our variables. I let x be the length of this side. So since this is a rectangle, so this side is also x. And I let y be the length of this side. So x is the length of each side perpendicular to the wall, and y is the side parallel to the wall. So we have two sides of length x and one side of length y. And the wall acts as the fourth side, so we don't need fencing there. Next, we identify what we are trying to optimize. We want to maximize the area of the garden. Because we want to maximize the area, so we want to use the formula for the area of a rectangle. Area of a rectangle is length times width. So we have x times y. Now, we use the fencing constraint. We have total of 100 feet of wire fencing, and we only fence three sides. So we have this side plus this side plus this side equals 100. So I have x plus y plus x equals 100. So the total fencing is 2x plus y equals 100. From here, we are going to solve for one variable. It doesn't matter if you solve for x or y, just pick one and solve for it. In this case, I'll solve for y because it's easier. So to isolate y, I subtract 2x from both sides. So I have y equals 100 minus 2x. Now we substitute this into the area formula. Y equals 100 minus 2x. So I will replace y with 100 minus 2x. This is the area function, and this function depends on the variable x. Now we have the area written as a function of one variable, which is exactly what we need. Now let's expand this. I'll have x times 100 minus x times 2x, which is 100x minus 2x squared. Now let's talk about the domain. Both x and y must be positive because they represent lengths. From this equation, y equals 100 minus 2x. Y must be positive, so that means 100 minus 2x is also positive. And I solve for x from here. First, I subtract 100 from both sides. So I have negative 2x is greater than negative 100. Then I divide both sides by negative 2. So I have x less than 50. X is greater than 0, and x is also less than 50. So my domain is x is in between 0 and 50. Now, we use calculus to find the maximum. In order to find the maximum value, we first need to take the derivative. 8 of x equals 100x minus 2x squared. To find a prime of x, I'll differentiate each term. The derivative of 100x is 100, and the derivative of 2x squared is 4x. So a prime of x equals 100 minus 4x. Now, let's find the critical numbers. Critical numbers are the numbers in the domain that make the derivative equal 0 or undefined. The derivative is a polynomial, so it will never be undefined. Now, to find the critical numbers, I'll set this derivative equal to 0 and solve for x. So I have 100 minus 4x equals 0. To solve for x, I first subtract 100 from both sides. So I have negative 4x equals negative 100. And then I divide both sides by negative 4. So I have x equals 25. X equals 25 is my only critical number for this problem. Now we need to confirm that this is a maximum, not a minimum. So we'll use the sign chart. I'll start with the number line. And my number line is from 0 to 50 because that is my domain. And I will place the critical number on the number line. So 25 is here. I need to check to see if the derivative is positive or negative in this region. And if the derivative is positive or negative in this region. In order to do that, I need to pick a test value. I want to pick a number in this region, any number that is in between 0 and 25. For example, number 1. And I take the number 1, plug that into the derivative. So I have 100 minus 4 times 1. So 100 minus 4 is positive. Now, I need to pick a test point for this region. You can pick any number in between 25 and 50. For example, I pick 30. And I plug 30 into the derivative function. 30 times 4 is 120. 100 minus 120 is negative. When the derivative is positive, the function is increasing. When the derivative is negative, the function is decreasing. The function goes from increasing to decreasing. So this point is a maximum. When x is 25, I will have a maximum area. We'll have maximum area if x is 25. Now, let's go back to the question to see what they're asking for. First, they ask for the dimensions, which means they ask for x and y. And they also ask for the maximum area. So we want to find x, y, and also the area. I have x equals 25. Now I need to find y. I use this formula, y equals 100 minus 2x. I plug 25 into this equation to solve for y. So y equals 100 minus 2 times 25. 2 times 25 is 50, and 100 minus 50 is 50. So the dimensions of the rectangle is 25 by 50. Now let's compute the maximum area. My area is maximized if x is 25. And when x is 25, y is 50. So to find the maximum area, I'll take 25 times 50. And that is 1,250. Now let's state the final answer clearly. The dimensions that produce the maximum area are 25 feet by 50 feet. And the maximum area is 1,250 square feet.